Good evening, students. Welcome to the class. Today we will start the class with the topic ionic equilibrium in solutions. Now, when we talk about ionic equilibrium, the name is suggesting that equilibrium between the ions. And as you know, ions can be obtained when a substance is dissolved in water. Then only the ions get separated from each other. In this context, you have to study 2 points, that is electrolytes and non-electrolytes. Now, what are electrolytes? Those substances which can dissociate or which can break into its ions completely, gets dissolved in the water completely, those are known as the electrolytes. And those substances which will not dissociate or which will not break down in ions in water, that substances are known as non-electrolytes. Electrolytes example is sodium chloride. Whenever sodium chloride, the common salt that we have in our food, that is the common salt. So when you will dissolve the sodium chloride with water, what will happen? It will break down into sodium ions and chloride ions. Okay, so it will break down into Na positive and Cl negative, right? So the breakdown is complete here. Okay, the sodium chloride is completely dissolved in the water, is completely dissociated in the water. So these are known as the electrolytes. And in a sodium chloride solution, the electrolytes are maintained between the sodium and the chloride. Now, when we talk about the non-electrolytes, what happens when we dissolve the acetic acid? This is an example of non-electrolytes. So, when we will dissolve the acetic acid in water, yes, up to some extent, it will be broken down into CH3COO, that is your acetate ion, and H positive. So it will be broken down into these two ions. But all the acetic acid, all the molecules of acetic acid will not break down or will not dissociate. Okay, so in a non-electrolyte solution, you will get more amount of acetic acid as it is, then some amount of acetate ion and some amount of hydrogen ions. Okay, and now in non-electrolytic solution, the equilibrium is in between the dissociated ions and the undissociated ions. So these are the 2 points that we have to study. The next topic is acids, bases and salts. This topic has come across because this also serves as some examples of the electrolytic solutions. Now, we have already studied the basic concepts about acid, bases and salts, right? So, when we talk about acids, the first thing that strikes in our mind is the tanginess nature, okay? So, the acids that are found in the human body, one example I would serve here is the hydrochloric acid. It helps in digestion. And for your information, that 1.2 to 1.5 liter per day is released by in the stomach, okay, in the human body. So it means more than 1 liter of hydrochloric acid is released in the body per day. Now, these are tangy in nature. These are also found in some fruits like oranges, lemon. In lemon, citric acid is found. Then in tamarind, tartaric acid is found. Okay, so here acids convert the blue litmus paper into red, and the same and the opposite goes for the bases, like it will convert the red litmus paper into blue. And bases are basically bitter in taste, and they are usually soapy. They form ladders, okay, like a soap. They are a little bit slimy to touch. Now, what are salts? When acids and bases combine together, they give us salts, and the combination has to be in certain proportions. Okay, the proportion has to be well established. Only then we can form the salts from acid and bases. Now, as you can see, there are 3 points here regarding the concept of acids and bases. There were different scientists who had different outlook for the acids and bases, and now we are going to study the different outlooks here. And this I have simplified by using a chart here so that you don't get confused between the different opinions. Okay, so the first is the Arrhenius concept of acids and bases. What it said, that acid are those substances which releases or which gives out hydrogen ions, okay, proton H positive, and bases are those substances which will release the OH negative, that is your hydroxyl ion. This is the hydrogen ion, and this is the hydroxyl ion. So Arrhenius said that So Arrhenius said that acids are those substances which releases H positive and bases are those substances which will release OH negative. Okay. Now, as an example, you can see hydrochloric acid. Okay, it is an example of Arrhenius acid because when it is dissociated, when it is broken down, what it forms? Two ions, that is your hydrogen ion, which goes according to this criteria, and the chloride ion. Okay, and for sodium hydroxide, it releases the sodium ion and the hydroxyl ion. So this goes along with the definition of base. So hydrogen chloride and hydrochloric acid and sodium hydroxide both are examples of Arrhenius acid and base respectively. I hope this is clear. The next definition is Bronsted-Lowry concept of acids and bases, and in the chart is given regarding the hydrogen ion. Okay, so Bronsted and Lowry said that acids are those substances which give out H positive and bases are those substances which accept the H positive. Now, in order to explain the example here, you will get two new things, and this example is little bit complicated than the usual examples because here is another concept linked. Okay, so now you please pay attention to the example. When ammonia is reacted with water, it will form ammonium ion and hydroxyl ion. Okay, now if you see that ammonia is forming the ammonium ion and H2O, that is water, is forming the hydroxyl ion. The definition of acid according to Bronsted is that it releases the H positive. Okay, now if you see here in the forward direction or in the forward reaction, what is happening? NH3H2O. Out of this compound, which one is releasing the H positive? If you see here, you can see that from H2O, one hydrogen ion is released, so you are getting OH negative, and the NH3 is accepting that particular H positive. So it's given here, acid will give out H positive and that H positive will be accepted by base. So if you observe here, you can see that H positive is given out by H2O and that H positive is taken by NH3. So this becomes the base and this becomes the acid. Now, there is another way of looking in the equilibrium that you know already, that we can look in the backward direction, okay, in the backward reaction. Now here, if you see, if you consider these two as the reactant, let us see NH4 positive, this is the ammonium ion and this is the OH negative. Now let us see that these are the two reactants and NH4 is becoming NH3 and OH is becoming H2O. So if you look in the backward direction, you can see that this particular species or this particular ion is releasing the H positive, and whenever it is releasing the H positive, it is termed as H positive. Clear? And OH negative. Now OH has become H2O. It has accepted, this particular ion has accepted the hydrogen ion released by it and it is becoming H2O. So this is the product. Now if you see in this direction, NH4 is releasing the hydrogen, so it becomes the base acid, and OH becomes the base because it is accepting the hydrogen ion. So this is known as the conjugate acid and this is the conjugate base. If you look in the forward reaction, this is the base, this is the acid, but if you look in the backward reaction, this is the acid and this is the base, and it goes properly with the definition of Bronsted-Lowry. Okay. The third concept is the Lewis acids and base, and it's very simple. So what happens? Acids are those substances which will accept the electron pair and base are those substances which will donate the electron pair. Okay. Now it is similar to this, but you see here accepting of H positive by base, but here accepting electron pair by acid. Okay. Now this is an example of Lewis acid and base. Okay, so you see here BF3 and NH3, right? So this is having some extra electron. this is having these two I have shown here, and these two are known as the lone pairs, and we will discuss about it in the chemical bonding chapter. Okay, so for the time being, you just remember that ammonia has 2 electrons extra on the nitrogen atom. Okay, and these extra electrons are called the lone pairs. They do not bind with any other atom, so they remain together. So these two are the extra electrons present, so it can release these electrons. So whenever any substance is releasing the electron pair, it is called the base. And BF3 is accepting the electron because this compound has deficit electrons, means it does not have the adequate number of electrons, so it is always in hungry of electrons, so it will take up that electrons, and these are known as the acid. Clear? So I think so this is clear to you all. Acids are those substances which will accept hydrogen ion. This will also accept. Okay, so you can study this chart and it will be easier for you rather than going one by one the definitions, because there are so many things going on here. Okay, one is accepting, one is donating, again hydroxyl ion is there, hydrogen ion is there. So in order to not get confused, please follow this chart so that it becomes easier for you. Okay, now base for acid, you see it gives Arrhenius said it releases hydrogen ion. Bronsted also said the same thing, but Lewis said that it accepts the electron pair. So these two sets you keep it means separate from these two, because the confusion is basically between this and this, because this is easier. Okay, only the thing here you have to remember is which one is accepting and which one is donating. Okay, so this much for today. You make the notes properly for this. Okay.